Tomorrow in class, we're going to start learning about different transformations that can be made on the quadratic function. Our parent function is y equals x squared, and it's graphed below in a dotted red. We want to compare every quadratic based on that parent function. The chart tells us the different types of transformations. We have a vertical shift, a vertical stretch shrink, horizontal stretch shrink, and a horizontal shift. And they're all based on what we do with the constant k, and that's going to be simply a number that's added or subtracted or multiplied to the parent function y equals x squared. In our first example, we have x squared plus 1. Notice our 1 is being added. It's not inside the parentheses, so we know that it's going to be a vertical shift. That means our graph should move up or down from the parent function. So if I graph these points, negative 2, 5 is not graphable on this graph. Negative 1, 2 would graph here. 0, 1, 1, 2. And if we connect those to make our parabola is going to look just like the red dotted one. It's just going to be vertically shifted up to 1 unit. Here's another example of a transformation. I want to compare the graph y equals x squared minus 2 to the parent function y equals x squared. Again, our constant, negative 2, is outside the parentheses. Therefore, it's going to be an example of this. We know it's going to be a vertical shift. So if I graph the points, negative 2, 2 would graph here. Negative 2, negative 1 would graph somewhere around here. I don't have room on my graph to graph 0, negative 2. I can graph 0, negative 1 would go here, and 2, 2 would go here. So if I connected my points to make the parabola, my graph would look something like this. Again, the same parabola shape, it's just shifted down 2 units. Vertical shift down 2. Next example, I want to compare the function y equals 2x squared to the parent function y equals 2x. Now notice this time the 2 is not inside the parentheses, but it's multiplied instead of added or subtracted. So it would look like it would be an example of the second type of transformation, where your k or your constants multiplied is in front of your function. So we know this is going to be either a vertical stretch or a vertical shrink. So if I graph the points, negative 2, 8, I can't graph this one on this graph, but I can graph negative 1, 2, 0, 0, and 1, 2. 2, 8 again is gone, is not on the graph. Notice this graph has the same minimum point, but it's much thinner and it will be much taller. Therefore, that will be a vertical stretch. Next example, I want to compare the graph y equals 1/5 x squared. My constant is 1/5. It is multiplied to the parent function x squared. So again, it's going to be an example of the second type of transformation because my constant 1/5 or k is multiplied to the function. I've put my table values here so I can graph it. If I have negative 2 4/5, that's going to be somewhere around here. Negative 1 1/5. 0 0 1 1/5. And 2 4/5. Now, notice how my graph is much shorter than the red dotted graph. It's wider, just as if you compressed it and you push down on the top of it. You're going to make it shorter and wider. That would be called a vertical shrink because you've made it shorter. Next type of example, I want to compare the function y equals parentheses 2x parentheses squared. Notice this time my constant 2 is inside the parentheses. Alright, so it would have to be an example of the third type of transformation, a horizontal stretch or shrink. I've placed my table values in here. Many of them are not graphable. But if I had negative 1 4, that would be like right up here. 0, 0, 1 comma 4, again way up here. To me, your vertical stretch looks very much like your horizontal shrink, because horizontally it's much thinner. So that would be called a horizontal shrink. Here's another example. I've included my 1/2 inside the parentheses. I want to compare parentheses 1/2 x parentheses squared to the parent function. So if I graph my table values, I have -2, 1, 0, 1/4, 0, 0, 1, 1/4, and 2, 1. Again, this looks very much like the vertical shrink, but we want to compare it horizontally since the number is inside the parentheses. And horizontally, this is much wider than the parent graph, so I would call that a horizontal stretch. Another example, I want to compare the function y equals parentheses x plus 1 squared. Again, this time my constant's inside the parentheses. So that's going to be a horizontal shift because it's added or subtracted. If I graph my points, -2, 1, -1, 0, 0, 1, 1, 4, and 2, 9 is too large to graph. But if I graph it, it's still going to be that same basic quadratic shape of a parabola. The graph is just shifted to the left, and that would be a horizontal shift left 1. I added a few points to my table since my values were so large. Tomorrow when we work on this, you might not want to include the values that are too large. So if I start graphing this, I want to compare x minus 3 squared. Again, the 3 is inside the parentheses, so you know that's a horizontal transformation. It's added, so it's a horizontal shift. The points I can plot are 1 comma 4, which would be way up here, 2 comma 1, 3 comma 0, and 4 comma 1. Connect my dots to make the parabola shape for the quadratic function. And they're identical parabolas. It's just shifted horizontally to the right 4. We're going to work on this tomorrow with GeoGebra and compare and predict what type and use our graph to see if we're correct. So let me know if you have any questions.